Very good, thank you. And thank you, Patty. So 2.5 exabytes. That is to say 2.5 billion, or for you geeks in the audience, any geeks out there? Yeah, 2.5 billion gigabytes of data is being produced every single day. If you're having trouble recognizing how big a number that is, think of it this way. That's about 650 billion Harry Potter books being written every single day. Now, not all of that is in a form that computers can operate with. In fact, not all of that is in a form that is necessarily literature, written materials. It is, a lot of it is, but most of that is in a form, about 80% of it is in a form that is largely different representations of our human expression. It could be text, it could be audio, it could be video, but nonetheless materials that classic computing systems have not been able to process and do anything with. This is the reason why we are driving this notion of cognitive computing, to be able to go in and understand that material, to be able to find information in all that information, in all that data that is relevant to our decision-making processes. These are the reasons why we're creating cognitive computing. So let me just spend a few minutes and tell you a little bit about what we mean by cognitive computing. We define cognitive computers as being systems that learn their behavior. They're taught how to reason about and how to look at the patterns of meaning in that information. They focus their attention on human forms of expression. That is the way that we describe the world around us, either in our literary form, visual or audio form, or even just the human condition that we get exposed to, the world as we experience it in all of its different variety, in all of its different modes, through all the different kinds of senses that we use to take in that world and reason about it. We think of cognitive systems as evidence of the same kinds of experience and expertise that we never normally measure in each other. That is, the ability to not only understand a problem space, but be able to reason about it, to be able to justify that reasoning, to be able to evidence confidence in that reasoning. And finally, cognitive systems evolve. They're not static. They're constantly being exposed to new forms of information, new sources of information, and new styles of reasoning about that for the purposes of doing a better job of amplifying our own cognitive capabilities. Now, within the Watson division, and now the Watson group within IBM, we've been applying this cognitive capability to a variety of industries, and we started primarily focusing on healthcare, addressing within the healthcare dimension the problems of how to do a better job of helping doctors find appropriate treatments for their cancer patients, to be able to look through all of the sources of clinical literature and find the very latest science that would be applicable to that decision, to be able to understand the patient involved, to be able to read through their clinical notes and understand not only who they are today and what kinds of disease they're presenting, the symptoms that they're presenting, and how perhaps they got to where they are, but also to look at their history, to look at their background, to look at their family history, to look at their similarity to other people in the population who may be similar by virtue of their genetics or similar by virtue of the kinds of environmental exposures they've had, and apply all of that along with the clinical reasoning processes that the best of the best doctors go through to understand which of the treatments that are available should be most effective in treating this patient. We've gone on to look at this in many variety of applications. In fact, we got so overwhelmed by the number of applications that people were presenting to us where they thought that they could actually improve human society or business by taking these cognitive capabilities and putting them in those environments, that we realized very quickly that this is bigger than us. This is bigger than IBM, bigger than anything that we could by ourselves make use of, and we needed to create an open platform. And so we brought this thing called the Cognitive Developer Cloud, or the Watson Developer Cloud, and we distributed that through ibm.com/Bluemix. Any developer, anybody can come to this platform, register, and begin to use our cognitive services to create your own applications, to bring your own value to the table, to create opportunities in new marketplaces through startup companies and entrepreneurship, through established approaches to market channels, by using these cognitive services. And today we've created 32 services that we make available on this platform, dealing with a whole variety of human conditions, all of which are informed by the cognitive experience, the idea that we can reason about how to translate somebody's voice into text, or we can translate between different languages, or we can begin to find knowledge in literature, or that we can reason about how best to trade off multiple different objectives when we're making a decision. All of those capabilities following the principles of cognitive computing. These are behaviors that are learned. These are behaviors that focus on human forms of expression. These are behaviors that evidence human styles of expertise. These are behaviors that are constantly evolving. Those services have been made available, and we have now over 77,000 developers using these services. We have over 400 ISVs who have registered to create applications using these services. We have over 100 applications in market being produced by our business partners and bringing those benefits to society. We've even done some work with universities. And what I'm about to show you is a project that the University of Texas Austin students produced in a 12-week period. They had a semester-long class where they learned about Watson, they learned how to ingest content, how to train Watson to recognize meaning in that set of content. They built a sample application that you're going to see here in a minute. They built a proposed business model for how they might take this application to market. They arranged a business partner to help sponsor them come into the market with their content around their business use cases, and they produced the video you're about to see, and they did all that in the same 12-week period. So please watch this video and see what these guys did.
Navigating social services is hard.
Plastic bag drifting through the wind, wanting to start again. Do you ever feel you're so paper thin, like a house of cards?
49% of the US population relies on some social service. That's a lot of people who have a lot of questions.
No one seems to hear a thing. Do you know that there's still a chance for you? There's a spark in you, you just gotta ignite the light and let it shine. Just don't.
Until now, the people who rely on these services have had to call the 211 hotline to get answers.
'Cause baby, you're a firework. Come on, show 'em what you're worth. Make 'em go,
At Call Scout, we created a better way to answer these questions. We partnered with the 211 call center in Austin, Texas, to create an app that uses Watson technology to help people navigate the complex world of social services. From healthcare to food pantries, the 211 app provides answers to the questions that matter most.
You don't have to feel like a waste of space. You're original.
The 211 app also allows people to do things that they previously couldn't over the phone, such as rating service providers and providing updates for the services that you use the most. The 211 app has been approved for a pilot by the state of Texas, and we're on track to make information more accessible to its 27 million residents.
So again, these are 6 students in college who created an application, the application that you saw being presented there. They approached a business partner to create an idea, and as a consequence of all that, we awarded those students $100,000 to go start their own company, and have since incorporated and have begun bringing this application to market. And this is one of hundreds of different ideas, different applications that different companies, startups in many cases, have brought to market using our cognitive services to benefit society. I want to emphasize, though, cognitive computing is about amplifying human cognition. It is a tool that when used properly can enable us to do what we do as humans in a more intelligent way. Cognitive systems most often are kind of doing our research for us. They're going out to the literature and reading through that literature and finding sources of information that are relevant to whatever decision we need to make, so that the decisions that we make, the thinking that we do, can be done better with the presence of this information. And it does it at an enormous scale, and it does it at incredible speed. Now, to do that, of course, we get some inspiration from the human mind. We look at how do people think about problems? How do they reason through that issue for the purposes of coming up with something meaningful? And these cognitive systems have to emulate some of that human reasoning in order to come up with information that is readily usable, that is intuitively obvious, that when people look at it will say, yes, that makes sense, and I know how to use that in the context of the decisions I'm trying to make. So we're constantly looking at the human condition. We're looking at human behavior, human psychology, sociology, and aspects of how we interact with each other and how we think about problems, so that we can tap into that massive quantity of information I mentioned earlier to help people make these kinds of better decisions. So I used to say that in the next 20 years, and then I decided I had to shorten that because things are moving so fast that now I start to say within the next 10 years. In fact, I'm on the verge of suggesting that within the next 5 years even, what we're going to find is that our world of computing, the things that we've been using computers for, which are largely about performing transactions or executing mathematical models, all of that is going to transform, and what we're going to find is that cognitive systems become the dominant form of computing in the future. The things that we do, even as simple as making decisions about how best to come to work, or to this conference, or what to do, or what to eat, and all those little decisions that we make, along with the big ones, will be assisted and informed by information that is otherwise inaccessible to us because of its magnitude, because of its pervasity in the world around us, to the point where we just simply are overwhelmed by it and unable to make use of it. It will amplify our human creativity. It will bring ideas to our minds that perhaps today we're incapable or aren't capable of finding time to produce on our own. It will find information and connect dots that we are otherwise missing. It will find interesting associations that will allow us to do a better job of discovering new medicines, or finding actors in a particular crime, or finding better ways of thinking through a problem. It will interact with us in our terms, rather than forcing us, as we have for the last 60 years, to adapt to the constraints of the computer. Computers are going to find us, and they're going to speak to us and interact with us in our normal human forms of communication, understanding our language, understanding our intention, and understanding the patterns of meaning that are hidden in that intention by our contextual history. And they will evolve. They will evolve to be more sophisticated and more practical and applicable over time. And they will do it with the benefit of the scale that computing systems can bring to the table. Thank you.